Hi, my name is Callie Furstenberg, and this is my curves, polygons, and symmetry final lesson for Math 1121. In this lesson, we will cover curves, polygons, and symmetry. So, I like to start with a brain warm-up for my classes. I think brain warm-ups are a great way to get your students' juices flowing, to get their attention, and to get their brain ready to be focused and paying attention. So, class, I have a riddle for you. How do you make the number 7 even without addition, subtraction, or multiplication? And division. You drop the S, so instead of 7, it's even. So, the learning objectives for this lesson are being able to understand simple, closed, convex, and concave curves and polygons, naming and classifying polygons, triangles, and quadrilaterals, and symmetries and their relation to planar figures. I pre-recorded my lecture, and I did this for my fellow students at home so they can also view the lecture. And so my students can always go back and view it if they need further questions or if they miss some things taking notes. So here is the lecture portion of this lesson. This is our symmetry, triangles, and curves lecture. So first we're going to talk about curves. A simple curve does not intersect itself, except the starting and stopping points may be the same on the curve that is traced. Closed curve can be drawn starting and stopping at the same point. A polygon is a simple closed curve with only segments and sides. Every polygon is either convex or concave. The difference between convex and concave polygons lies in the measure of their angles. For a polygon to be convex, all of its interior angles must be less than 180 degrees. Students, I also suggest that you are taking notes right now, as that will help you later in this lesson. Otherwise, the polygon is concave. So, let's take a look at figure A here. Let's determine whether this is convex or concave. Turn to a partner and discuss. Awesome. Now that you've discussed with your partner, what is this, convex or concave? That is correct. This is convex. Now what about B? Let's all shout it out. Is this convex or concave? Awesome. This is concave. Is this convex or concave? 3, 2, 1. Great. This is concave. What is D? Convex or concave? Chat with the partner. D is convex. That is correct. Is E convex or concave? E is concave. That is correct. What is F? F is convex. Correct. So here we are looking at a few different figures that are simple closed polygons, convex, or concave. These are good examples. You guys can jot this down or take a picture of it with your iPads, whatever you feel is best. So let's talk about this curve. This curve is simple, but it is not closed, a polygon, convex, or concave. Let's look at this figure. This figure is simple, but it is not closed. Therefore, it is not a polygon, convex, or concave. Let's look at this figure. It is simple and closed, but it is not a polygon, it is not convex, but it is concave. Let's look at this circle. It is simple and it is closed. It is not a polygon, but it is convex. Let's look at this figure here. This figure is simple. It is not simple. It is closed. There is no open lines here. Yet it is not a polygon, convex, or concave. This figure is simple, closed, a polygon, and it is convex. This figure is simple, closed, polygon. It is not convex, but it is concave. And this last figure here is simple, closed. It is not a polygon, but it is convex. Are you guys starting to get the hints here? So, talking about polygons, let's talk about classifying them. We classify polygons based on the number of sides or verticals they have. So we all know what a triangle is. It is a polygon. It has 3 sides, and this is what it looks like. So, based on the number of sides, we can tell what type of polygon it is. So if a polygon has 4 sides, it is a quadrilateral. If it has 5 sides, it's a pentagon. If it has 6 sides, it's a hexagon. If it has 7 sides, it's a heptagon. If it has 8 sides, it's a octagon. If it has 9 sides, it's a nanogon. And if it has 10 sides, it's a decagon. And so on. So each polygon has polygonal regions. There's an interior and an exterior of all polygons. So what is an interior versus an exterior angle? Well, 2 sides of a convex polygon having a common vertex have an interior and an exterior angle. Here you can see the interior angle right here in this polygon, which is D. And here you can see this exterior angle of the polygon right here. Does anyone have any questions so far? No? Awesome. So here's a video on classifying triangles.
This diagram summarizes the different types of triangles. However, I find it a little confusing. In this video, I will break down the major types of triangles and how they can be classified. Welcome to Moo Moo Math and Science. A triangle is a 3-sided plane figure with 3 sides and 3 angles. The sum of the 3 angles always add up to 180 degrees. Up first are triangles that are classified by the length of their sides. This picture summarizes the 3 triangles. A scalene triangle has 3 different side lengths. You can tell this by the different tick marks. An isosceles triangle has 2 congruent or equal sides. And an equilateral triangle has 3 congruent or equal sides. Triangles can also be classified by their angles. There are 3 angles that are often associated with triangles. Acute angles are less than 90 degrees. Right angles are exactly 90 degrees, and obtuse angles are greater than 90 degrees. All triangles have 2 acute angles, and it's the third angle that determines the type of triangle you have. Let's look at the classification of triangles according to angles. An acute triangle is a triangle with 3 angles that measure less than 90 degrees. An obtuse triangle is a triangle with 1 angle greater than 90 degrees. And a right triangle is a triangle with 1 angle that is equal to 90 degrees. You can also classify triangles by the side length and angle measure. This chart summarizes triangles classified by side length and angle measure. A scalene triangle, remember, it has 3 different side lengths, can be acute, right, and obtuse. An isosceles triangle, remember, it has 2 equal sides, can also be acute, right, and obtuse. And an equilateral triangle can only be acute because in order to have 3 equal sides that are equal, the angle measures must be equal to 60 degrees. If you'd like to know more about triangles, this playlist will help.
Awesome. So now we are going to be talking about classifying triangles.
This diagram summarizes the different.
A great intro video of how to classify triangles. So there are 6 types of triangles, and you can classify them by sides, So an equilateral triangle, an isosceles triangle, and a scalene triangle. An equilateral triangle has 3 equal sides, as you can see in this figure right here. An isosceles triangle has 2 equal sides, and a scalene has no equal sides. You can also classify by angle. An acute triangle has 3 sides that are less than 90 degrees. So in the video, it said that they are 60 degrees. A right triangle has one angle equal to 90 degrees. That would be in this corner right here. And an obtuse triangle has one angle that is greater than 90 degrees. So that would be in this corner down here. So now let's talk about quadrilaterals. A quadrilateral is a type of polygon that has 4 sides and 4 verticals. So here's some different types of quadrilaterals. We have a square, a rectangle, a parallelogram, a trapezium, a rhombus, and a kite. So a parallelogram is a quadrilateral in which each pair of opposite sides is parallel. So here's an example right here. This is a parallelogram. A rectangle is a parallelogram with a right angle, as you can see in this corner. A rhombus is a parallelogram with 2 adjacent sides that are congruent. And a square is a rectangle with 2 adjacent sides. If you guys want to be taking notes on this, that would be advised. So, symmetry and planar figures. Geometric figure has a line of symmetry of its own image, one folded along the line. So here, A, B, C, D, and E are all examples of symmetry in these figures. And also, this is a more complex symmetry figure here. So rotational symmetries. A figure has turned symmetry or rotational symmetry when tracing of the figure can be rotated more than 0 degrees and less than 360 degrees so that it matches the original figure. So see here, this has turned 180 degrees and it is still the same as the original figure. The recycling sign is also a great example of a rotational symmetry, and same with a star. Triangle, triangle. This is rotating 90 degrees all the way around. So there's also point symmetry, and that is any figure that has 180 turn symmetry and is 10-point symmetry around the turn center. So here are all examples of point symmetry. As you can see, here's the point, and the symmetry follows. So now we are done with the lecture, and we will be doing the next activity. Great. So if you guys ever want to go back to that lecture, it will be on our webpage. I do post all my pre-recorded lectures on there. So, okay. Do you guys have any questions after the lecture? Anything I can clarify? No questions? Great. So our next activity, we are going to find a partner, and I'm going to be passing out these sheets, and we are going to be practicing what you guys just learned. So with these sheets of paper, you guys are going to cut out the triangles, and then you are going to be getting with a partner and trying to figure out what each triangle is, based on what we just learned in the video. So if you guys want to get in partners, I'm letting you guys choose today. So have fun with that. And then we're going to be doing this for about 15 to 20 minutes. If you guys have any questions, I'll be walking around. And then after this, we'll be moving on to the next activity. Great. So you guys finished that activity. Awesome job. You guys seem to know what you've learned and what you're talking about. So we're going to test your knowledge even farther. And so I'm going to be handing out this worksheet, and you guys are going to be working on this independently. Okay? And so on this worksheet, you're going to be writing whether each polygon on the sheet is concave or convex. You guys can always go back to the video, or you guys can refer to your notes that you took during the lecture video. to help you answer these questions. This is practice for our quiz that we are going to be having at the end of the period today. So just be sure that you guys are really paying attention and that you guys are trying to focus as much as possible. We will be doing this for about 20 minutes as well. If you guys need more time, we can always have more time, and I will be walking around and checking in with everybody, seeing if you guys have questions or concerns. After you have finished this worksheet, you can come up to me, and then you will have permission to go take your quiz on quizzes. I have emailed you guys all the links, or you can copy these links here from this PowerPoint. And so the first quiz we are going to have is on symmetry, and that's only 10 questions, so it shouldn't take you guys too long. And then the second quiz we are going to have is on curves. So this is a great way to assess your knowledge, to see if you picked up anything from the lecture videos. If you guys have any questions at all, please let me know. And that's the end of this lecture. I hope you enjoyed.